This task begins with the development of a function that will return one of three strings, either the word rock, the word scissors, or the word paper. So let's leave a few lines and just start constructing this function. Don't worry about the meaning of the words private and static. Because it's a function, it will return a value. The data type of that value will be string, and in the Java language we have to state what's called the return type of the function. So this function always returns strings. Let's call it getChoice, and let's open curly brackets and get going. So let's begin by building an array of three strings, and we'll call it choices, and we will say that there are three strings available, 1, 2, 3, and let's turn on maybe caps lock and type them in. So rock would defeat scissors, and scissors would defeat paper. Next, having developed a list of options, a selection of options using an array structure, what we can now do is generate a random number in the range 0 to 2 inclusive. So that means that we have a couple of options here. I'm going to opt to use the class in Java called random, and I'll just build a variable called rand. If I just pause there for a moment, I'm going to let the NetBeans IDE help me here. The random class hasn't been imported yet. It does exist. It's available for importing. So I'm going to let the NetBeans IDE put in this line of code for me. Next, I'm going to continue this and say I want to build a new variable of data type random. So in order to get this to work, I want to be able to use this special variable to pick one of the three values from in here. So I know that I'm going to be returning a string, and that string is going to be found in the array of choices at a particular index. In order to provide that index in this gap, I'm going to use the special variable called rand. It comes with a built-in method. So I type in the dot, and I want to get the next int. So if I start typing that, there we go. But I'm going to use this version of the method where it has a bound, it has an upper limit. I'm going to set that upper limit to be 3, and that will mean that the possible values are going to be either 0 or 1 or 2, excluding the number 3. That completes the function. So we can just test the function very quickly. We could do some system.out.println statements, and we simply call the function like this. And then what we could do is we could enclose that inside a for loop. FORI tab will assist us to quickly develop a for loop. Let's cut that statement. Let's paste it inside the for loop. And let's change this to a testing number, let's say 10. And if we set our project as the main project and we run this, it should develop 10 different choices for us. We can see that they are somewhat random, somewhat scattered. If we run it again, we'll not get exactly the same 10. You can see a little bit of bias maybe in that one, paper only occurring twice, and so on and so on. Very heavily, predominantly choosing rock there, and paper, no mention of scissors. This is entirely random. If we repeat the experiment more times, then chances are that things will be distributed somewhat differently. If I do control and scroll there to zoom out a little bit, you'll see there's a very different distribution there. So confident that the function in itself is working, let's now give some thought to how will we turn this into a game where it automatically plays like a simulation of a two-player game. So we can comment out the testing code. We can keep it there just in case we want to go back to it at any point. But let's get going with the main method, the main task that we're here to do. So let's establish the scores for two players. So let's have an integer variable called player1 score, set it equal to 0, and do the same thing for player2 score, set it equal to 0. What's going to happen is that the function is going to be called multiple times. Each time a round of the game gets played, player 1 uses the function to pick one of these three at random because it's a simulation. Player 2 does the same, and then the two results are compared with each other to determine the outcome of that round, which might in turn affect the scores. However, there is the possibility that both player 1 and player 2 will opt for the same item. In that case, if they both choose, for example, rock, then neither of the players' scores is going to be affected by that. So, in that case, we are going to continue to play another round. So, theoretically, we could play 1,000 rounds and there could be 1,000 draws before we get anywhere and before the gameplay really gets going. Really, in theory, there could be millions, billions, trillions of occurrences of draws. And if there was some sort of a flaw with the generation of random numbers and it did always lead to the same results, that eventuality is a very real possibility, something we might want to put in some sort of defense against in our program. But that's a real afterthought, and it's not really within the scope of the task. It's just something that we might have to be cautious about a never-ending game. So in this case, once the players have played 3 rounds where their scores have been changed in some way, that means that we know that the game has ended. So we can keep doing what we're doing until the sum of the two scores crosses the line of being a 3. In this case, because the quantity of iterations of the game is indeterminate, we don't know how many there are going to be, we're going to use a while loop rather than a for loop in this case. So I'm going to say while something, go ahead and play the game. And my criteria here are going to look like this. Whilst player 1's score plus player 2's score is less than 3, we keep going. So what will happen each time is both of the players will have to make a selection. Outside of the while loop, let's create 2 string variables. We're going to call it player 1 choice and player 2 choice, like this. Using the comma simply provides us with a list of string variables. We're not going to initialize either of them. So player 1 choice is going to become equal to, and we're going to call our function to do the work for us. We've already checked the function, we're happy that it works, so we can go ahead and do that. Similarly, by the power of copy and paste, player 2 is also going to make their choice. We then proceed with deciding the outcomes of the game. So they have both made their choices, they are random choices just as they would be in the real world. We're going to now make a decision. Either the two of them have drawn, and in that case the scores are not affected and nothing else will really happen. We can produce some output just to show what's going on within the game. The second possibility is that player 1 has defeated player 2, and if neither of those two possibilities come out, it's not a draw, and player 1 has not won. The only remaining possibility is that player 2 has won. And so we begin. If player 1's choice, which has the data type string, is exactly equal to player 2's choice. To check if the two strings are equals, in Java we use .equals. So if player 1's choice is equal to player 2's choice, the NetBeans IDE has helped me here by locating a previous string and putting it into the equals brackets. So if the two of them are equal to each other, then what? Well, let's use system.out.println and let's say a draw has occurred, and we'll just say play again. Okay, so otherwise, if, now this is more complex, how do we know that player 1 has won? There are 3 possible criteria. The first one is, let's set up some brackets ready to go. So the first possibility is that player 1's choice was equal to, let's use .equals, player 1's choice was equal to rock, and at the same time, let's scroll across, player 1's choice was equal to rock, and using copy and paste for speed, player 2's choice was equal to, well, what would be defeated? If it's a rock, then it's going to be scissors. Now that's one possibility. If that occurred, that would mean that player 1 has won. Let's take a copy of that entire expression. Then let's force a new line and put in the OR operator just here, because there's a second possibility. The second possibility is that player 1's choice was equal to, let's say, paper, and paper is going to defeat rock. We're going to do the same thing again, forcing a new line before the closing round bracket of the if statement and typing in the OR operator and pasting once more. Here, the third possibility is player 1 has chosen scissors and player 2 has chosen paper and ends up getting defeated. If we move the sidebar across a little and use Alt and scroll to zoom out, we can kind of see our general Boolean expression as a whole. So if player 1's choice is rock and player 2's choice is scissors, or any other combination where player 1 comes out as the dominant choice, that means that two things are going to happen. We're going to announce that player 1 has won. Player 1 has won this round. Okay. And then we're going to increment the score held by player 1. We have already declared and initialized the player 1 score variable. So after printing this, we can use player 1 score plus plus to quickly increment the score. So option number 1 is that the game is a draw. Option number 2 is that player 1 wins the round. And finally, that leaves only one other possibility, which is that player 2 has won the round. So we no longer need to construct a complex Boolean expression because we've taken out all of the possibilities. And so, using copy and paste from these lines, we can say that player 2 has won, and we can say that player 2's score gets incremented. The while loop started here, and we're going to keep doing this set of operations until eventually the sum of the two scores does become 3. I'm going to single click on this opening curly bracket. Scrolling down will assist me to locate the closing curly bracket. So will the grey guidelines that run down the way in this integrated development environment. Let's now announce the winner. I'll use Alt and scroll again to zoom in slightly. If player 1's score is greater than player 2's score, then that means that we can announce that player 1 is the winner of the whole thing. Copying and pasting this line of code from earlier, we can quickly construct a sentence. Player 1 has won the entire game. If player 1 has not won, then the only other possibility is that player 2 has won, because this block of code is unreachable until the while loop terminates. The while loop will terminate when the sum of the two scores reaches 3, and that will only happen when one of them is 3 and the other is 0, or one of them is 2 and the other one is 1. So we know that we can't progress when the two scores are identical. So the only other possibility here is that player 2 has won the entire game. This looks like a viable final answer for the entire problem, starting with the function that returns one choice, which we've tested, and moving on to the game itself. One way to identify bugs in the game is to go ahead and run it. So let's run it. So player 1 wins the first round, player 1 wins the second round, there's been a draw in the third round, player 2 wins the third round. Overall, player 1 has won the entire game. Running it again. There was a draw at first, player 1, then 2, then 1, won their 3 respective rounds. Therefore, altogether, player 1 has won the game. This gives pause for reflection, because if players 1 and 2 both win a round each, in this case, then that means that you have to play the third round. But if we were to go back to, it's not so simple to go back to, but if we look at this situation, player 2 has won 2 of the rounds, and therefore has won the game early, maybe we could adjust our algorithm.